We're explaining the installation of a Viking aircraft engine in a just aircraft. This happens to be a super stall. This installation is very similar to all installations, and we'll deviate slightly when there's a difference, such as high wing, low wing, and so forth. The first thing you want to do when the engine arrives at your location is take an overview, but then physically you want to hoist the engine. Level your airplane, make sure it's stable. Grab the engine through these strong points here. If you are using the outboard engine mounts to mount it to the engine mounting structure, then you can hoist from the inboard mounts. There's inboard and outboard mounts. If your engine mount attaches to the inboard, use the outboard for your hoisting. Now, what we like to do is just use 4 ratchet straps, because that allows you to fine-tune the way the engine is hanging in your hoist. But whatever you do, make sure it's safe and that you cannot drop the engine. Once the engine is level in front of the aircraft, obtain your engine mount. Bolt the engine mount to the airframe using the hardware supplied by the aircraft manufacturer. Some adjustment to the lengths might be required because of the Viking engine mount deviating from the standard engine mount. So you would have to measure that and obtain the right AN 4, 5, or 6 bolts from aircraft spruce, and the number of washers and the lock nuts and everything that's required there. Now at the engine side of the mount, where the steel structure bolts up to the rubber donuts, the hardware is supplied by Viking, and it consists of the bolts as well as AN6 washers, little washers, the large area washers that are on each side of the 2 rubber cups that sit in this machined pocket, and then the required nut and washer at the other end. Tighten this down until you feel that the bolt is bottoming out. There's actually a steel sleeve inside the rubber. Once it's tight and you feel steel hitting steel and there's no more sponging of the rubber, then just another quarter turn and everything is at the right torque. You don't want to over tighten that. That includes the physical mounting of the engine itself. Now we're going to cover some of the things that you will be required to do, one of them being, for instance, the fuel system. The fuel system on the engine consists of 4 fuel injectors, cylinders 1 through 4. The task at hand is to obtain the required materials and hoses and clamps, which are in the Viking grab bag. Now, if you have purchased a Viking grab bag, everything about the installation will be so much easier. If not, you'd have to obtain these items on your own. You will use 5/16 fuel injection hose clamp, not regular hose, but fuel injection hose. You will use Oetiker clamps, and you will use O-ring grease. This particular installation or attach point is probably the toughest one to get together, because this fuel rail was originally designed for a slip-on plastic fitting. Now we're using a slip-on hose. So you'd want to take this hose and put it in hot water to warm it up. Put quite a bit of O-ring grease on the metal itself. Put your clamp here ahead of time, and then push the hose on, like really just kind of push hard, and eventually it'll let go and it'll go over the first barb. Slide your clamp on and then squeeze it with your pliers. So it's over the first barb and up to the second barb. Then go through the firewall. In this instance, we went right through the firewall with a grommet because it just was a very straight shot. The engine is very close to the firewall, as you can see in this particular airplane. You can also obtain firewall pass-through fittings and such. From there, we try to minimize the breaks of the fuel system. And in fact, in this airplane and in most installations that we do, this hose will now continue on all the way behind the pilots and into the aft portion of the aircraft. And in, for instance, like a Zenith, it would be way past the rear bulkhead and out of the cabin again. In this just aircraft, the header tank is mounted in the cabin, but it is behind the pilots in the rear part of the airplane. Now, the header tank is a product, actually, that's sold by Viking aircraft engines, and it is called a fuel system in a box. And why is it called a fuel system in a box? Well, because it contains everything that is required as far as a fuel system to run the Viking engine. Those items is a system that has two fuel pumps, a primary and a backup, a pressure regulator to maintain 41 psi of fuel pressure, pressure transducer in order to display the pressure on the instrumentation of the Viking view in the cockpit. It has the low pressure filters to filter the fuel. It has the high pressure filter to filter the fuel as it exits the fuel pumps prior to going to the engine. It has the inlets for the fuel as it comes from the right and the left wing tank. And it also has a fitting for a hose going back up to one or the other tank in order to purge and vent air out of this tank. So it's a very complete system. It is available from Viking. For all high wing aircraft, it's highly recommended. It also has a nice feature where you can read the fuel in this tank, 2.5 gallons of fuel, and you have a gauge on the panel with a sender unit that's provided, and it tells you that you have 2.5 gallons left in the airplane, whatever you want to use that for. We think it's a great idea because some people might explain to you, oh, that's crazy, 2.5 gallons, why would you ever want to fly with that little fuel? Well, that's not what it's about. What it's about is that when you're flying in your light sport aircraft, if you're carrying 5 to 6 gallons per side in your wing tanks as an additional fuel just because you're not quite sure what the fuel gauges are reading, that's an awful lot of weight when you add it up. The designers of these planes have been very frugal about the size of the tubing and how they've built this airplane, and carrying all that extra fuel is not really necessary just because you're uncertain of your fuel gauges. The nice thing here is that you can run your wing tanks a little bit lower and not worry about it because you have a visual indication on your panel in a gauge of your last 20 minutes of flying. Doesn't mean you'll ever use it, but it's there and it gives you that peace of mind. Now, we've got that fuel hose coming up this post here, and it goes to a high pressure filter back here. You'll see this when you picture this header tank in pictures on the Viking Aircraft Engines forum. You'll see the pumps, you'll see the pressure transducer, you'll see the low pressure filters. You'll be able to see things like, and we'll show them here as well, a drain. This goes to a drain. There's a drain in the aircraft here where you can drain sediments and water out of the bottom of the tank. You've got your return hose fitting right here coming from the fuel pumps on the back side. You've got your low pressure filter fuel coming here going to one pump, and the same on the other side. So it's a very complete setup and highly recommended. If you don't go with a header tank, you would then mount your fuel pumps somewhere in the aircraft. You would, for instance, well, let's just talk about a low wing. If you had a low wing aircraft, you would not use a header tank of this style, but you would use a 6-port fuel selector valve, and you would run fuel back to your fuel. Fuel that's coming from the right tank would run back to the right tank. Fuel that's coming from the left tank would run back to the left tank. And that's a special fuel valve, and you can find that in the Viking Aircraft Engine shopping cart under duplex fuel valve. And there's also pictures on the forum about how to do that kind of an installation. So, fuel system in recap, coming from each wing, going into your tank, being pressurized, running up front here to the engine. All the filters are provided, all the wiring is provided. You have to then, as we get into the wiring description here, do more detailed wiring, but we'll get to that. So that covers the fuel installation. We're going to go back up front and we're going to look at some other things that need to be installed and hooked up on this engine for it to become a working engine in your aircraft. Let's cover the cooling system. Now, the engine is put together traditional by Viking. Everything is always put together for the customer, so your radiator is already here. Hot coolant will come out of the engine in this location, and it will go either up through this bypass, through this thermostat housing, sending the coolant this way, or it'll go down and then being cooled by the radiator, and then going up this side, going right back into where the coolant pump in, and pumping it around through the engine, and it just goes around and around like that. What you have to do is very minimal. Now there is one piece that's mounted to the firewall. There's a hose coming off here, and you would run this to the other side of the engine or this side, depending on where you have room to put your coolant tank. The coolant tank in this installation is over here. We have this size tank and we have some smaller tanks. This one just happened to fit very nicely in this area. And the hose you saw up there, and that terminates right here. We have just a squeeze clamp on that. What you do want, depending, is always to have coolant above the inlet of this hose. It doesn't matter if the hose comes in from the top or it's on a nipple on the bottom. What matters is it has to be submerged in coolant at all times. If the tank is below the engine or the tank is above the engine, it doesn't really make any difference because you're not filling it here. It is just vacuum created by the engine heating up and cooling down that either pushes coolant into this tank or draws coolant from this tank through the little hose you saw. The actual filling of the coolant can be done here if for some reason it's getting low over a very long time, but the initial filling is not done here. It is done here on top of the engine. You remove this plug. What we usually do is get a plastic funnel of the right size and screw that into the threads and put some rags around here so you don't make a mess of your engine, and fill the NPG coolant that's in your grab bag. Don't use any other coolant because the engine is not approved for any kind of water-based coolant. It will cause corrosion and it causes pressure. We do not run any pressure in this. This is an open vented system, so there's no pressure cap like you're familiar with on your motorcycle or in your car, which is a safety benefit for the Viking engine. By running no pressure and a lifetime coolant, we have a very safe cooling system in the engine. So fill it here, add coolant to your funnel, let it sit and purge, and eventually it'll come out this and it'll start filling your coolant tank. And then as you're running and idling the engine, you want to keep adding coolant to your coolant tank. And that's all there is as far as the coolant system that you have to do as far as coolant. Now there's also oil that needs to be cooled. So we're going to cover the installation of the oil cooler next. The oil cooler itself comes to you with brackets, and it is mounted to the inboard engine mounting bosses of the engine at the bottom. In addition to the bolt that runs and holds the rubber donuts and bolts the engine to the mount, a longer bolt has been implemented in the newer installations that Viking is doing now with a spacer, and that's true on both sides. In fact, in this particular installation, we'll show on the other side that everything was so close to the firewall that we had to space the engine out a little bit more on the far side than on this side. Sufficient to just mention that. Once this is tight, then the oil cooler will hang here, and the 2.5-inch scat duct will be added to here, and a NACA, plastic NACA inlet is pop riveted to the cowling, and it feeds air in through the oil cooler and then of course down and out through the bottom of the airplane. You have to add the metal hoses, braided hoses to it, tighten them to the back side here on both sides. Sometimes these new hoses that we're getting are very stiff and they seem like they wouldn't even fit, but with a little bit of finagling and moving them around, definitely use ADAL clamps to keep them off structure. This braided stainless would actually saw into your engine mount. You don't want that. And just keep them supported all the way up to the engine, and tighten them down onto the engine. Sometimes they might have to come in at different angles to make all this work. Once you have that done, then your oil cooler physical installation is done, your hoses and the mounting of the unit itself. Other things that you have to mount before we get into electrical is you might have to put your muffler back on, because more times than not the muffler is shipped separate to the engine. So you grab your hardware, which consists of lock washers and regular nuts, and your sandwiched shim, the gasket, stainless steel, and you bolt this up and tighten these to 280 inch-pounds. and that's all there is for the muffler. Eventually, you might also hold off a little bit. Sometimes you might not want it if you are trying to fit your cowling or find out exactly where your hole in the cowling would be. You might want to hold off and putting that on until the cowling is installed, and then do a plumb bob and figure out exactly where this hole is, and so forth and so on. So, but that's up to you. Those are minor adjustments to the installation. Now let's cover the crankcase venting of the engine. These newer Viking engines have a crankcase vent on both sides of the engine. This cover is vented here. It has an oil separator built into it, and crankcase venting pressure comes out here and just turns 90 degrees and goes through a hose out on the bottom. Now we're going to go on the other side and show the venting there, and then see how they come together at the bottom. There's a crankcase vent here. This can be replaced at times. This is the venting filter with a 5/8 hose that also just runs overboard, and they just run down the firewall, make sure it doesn't chafe into your pulleys or anything like that, and then they both just exit at the bottom. This is from the other side, and then this one. Now, while we're in this area, this is also an area where you would fill your oil. Okay. We always like to keep a little bit of O-ring grease on these things so it slides in and out easy. Of course, eventually it'll slip on easy enough anyhow. When you purchase these filters, of course, this comes with your engine, but if you want a replacement, take some Right Stuff. It's in your grab bag, and smear it around here, because this is a pressed together piece and it can leak, so we just take care of that ahead of time. This is also where you would check your oil level. You have a dipstick that comes with your engine. Two little dimples indicate your minimum and your maximum oil. You fill the oil right here, of course. As we're on this side, let's just cover things as we see them. Your engine will have the alternator installed. You have to provide some wiring to get the alternator completed. We're going to cover the entire wiring diagram shortly, but a 60 amp fuse gets mounted to your firewall. It's in your grab bag. There's a number 8 wire or cable that goes to the input side of this fuse, and it starts at the output terminal of the alternator. As you can see, extremely important that this wire, this cable, is strain relieved to the alternator itself. You don't want this to go directly to the firewall, because the engine and the airplane is vibrating at different frequencies due to the rubber donuts. So we have the cable securely secured to the alternator itself, which means when the alternator is vibrating, there's no strain on this wire. And you'll see that throughout the entire installation, and it's very important. Your electrical system is important on the Viking engine. The other wire that you'll see here is for the field. It goes to what we call the top of the T. The 2 terminals back there make the shape of a capital T. Now it's laying on its side, but it still is a capital T. And this goes to the top of the T. And that wire is going to your ignition switch, and we'll explain exactly why as we cover all the wiring. Now, in this area, there's a couple other things we can mention. For instance, your throttle cable. Your throttle cable is from aircraft spruce. It has to be this exact type with a 1032 end on it. The engine is supplied with this swivel joint right here. The clamping arrangement back here is set up to have a washer here on both sides and then a nut. If you don't have the washer on the back, it'll clamp this too hard. One extremely important thing here, which very difficult to get people to understand for some reason, is that this little dimple in the back here has to be in the groove of the cable. If the dimple is not in the groove of the cable, then this will slip out and you have now no throttle at the worst possible time. So such a little detail is important. That little dimple right there has to be in the groove, and you can feel that by moving this around a little bit as you tighten these nuts. until it is where you want it to be. Then up here, this gets attached. This will pop off like this, and the throttle can now move freely. Let's cover this part first. Viking has engineered a spring-loaded ball right here in the back of the idle adjustment screw. You set your idle with this pulled back to this point. With the propeller on and the engine at operating temperature, the RPM should now be 1750 RPM. When you pull this back, this is another low idle. You pull back the throttle, it's spring-loaded, and you let go, it goes here. We use this feature for shutdown. You pull back, and then you you turn off your ignition, and the engine will nicely spool down and shut down without any kind of backlash and wobble. It's a much nicer way to shut down a geared engine. You can also sometimes use it on the hot engine that's already been run that day. Pull it back and start it and let go. It's also a softer start. I use it a lot when I taxi. If I come up to a intersection, rather than jumping on the brakes, I pull my throttle back a little bit. Now the gearbox is going to make a little bit of ticking noise when you do that, but it's not harming anything, and it's not permanent, because you can let go of it when you come back out of a turn or something taxiing, or if you're taxiing downhill, or if you're on the water on a seaplane, and it has all kinds of uses. You're on short final, the prop is spinning a little bit too fast and you want to drop down faster, pull your throttle back. Okay, now this, what you do is you rig the throttle up and you make sure that when this is out, you can push it down to where the ball is without forcing it. See, it goes right down. When it's back, you push this back, you make sure you can lift it up here to where it needs to be without bending back here. This is what makes for a nice seat. We're just making it here. We got another 1/8 inch. We have to actually lower it back, and then it pops back on. Now what that does, it causes a very smooth throttle operation with no forcing it anywhere. And I can do from here, I can pull it back. The other thing you want to do is when it's hooked up correctly, this should now turn freely and easily. It should not be jammed up one way or the other way. That means that there's a twist in there, and you could undo that by holding this with something that's crude as vice grips. There's no other real way to hold it, and then tighten this lock nut back up. So now, as far as the throttle going forward into the cabin, by the way, this is a ASC Products, which is Aircraft Spruce, and it's an A800 cable, and it has a friction lock system in the cabin. Don't just try to use some kind of local cable or something that's not exactly this part number, because what you're going to do is going to cause a lot of grief for yourself, and it's not going to fit the manifold. The distance of everything and the size of everything has to be exactly this, so that it just bolts up and works. So that covers the throttle cable installation. Now, let's talk a little bit about your instrumentation, since we're right here at the engine and we're looking at the sensors that are going to feed this instrumentation. We recommend, of course, that no matter what instrument you have in your airplane for navigation, even with a nice EFIS screen, that you end up using the Viking View instrument. And this is not because Viking is after selling this and selling that. It's because we have tried this over the years, and we know how easy it is. And it's ready to go. You turn the switch on, everything works. There's nothing more frustrating than having an EFIS system that takes you several months and most of your 40 hours of fly-off time to try to figure out how to get your oil pressure and your tack and all this stuff to work. The Viking View is designed for the Viking engine. It plugs in and it works. What we've got here is the temperature probe, and then right over here we have a few other sensors. This is very simple. We have coolant temperature, and we have oil pressure and oil temperature. Those are the things that feed the Viking View and tells it what to display on the panel. Now, the harness for this is already installed on your engine, or if you didn't order the instrument with the engine, it would be easy for you to install following directions on our website. Now, this harness just plugs in here. There's a DB9 connector right here, and The harness then goes through the firewall. By the way, going through the firewall, we use these nylon grommets from Aircraft Spruce. Half of this one is installed. The top will be put on once everything is completed. Search under nylon for all things on Aircraft Spruce, and this will be one of their nylon parts, and it's a pass-through for the firewall. Now, the Viking View harness goes through here, and then it just goes up to the instrument itself, and it plugs in on the backside. By the way, there's all kinds of shells and things coming with these, and to me, it's for nothing. This is already inside the plane. I don't use all the shells and all the stuff that goes on here. I just make sure that my wires are safe tied, so there's nothing pulling on this, and put a couple of screws in there, and that's how I prefer it. The instrument itself gets mounted here in the panel anywhere you want. We're going to turn power onto it, and then you can see some of the features that it has. The thing that's different about the instrument, because it is basically what's called an EIS, Engine Information System. Well, what's different about this is that we worked with that company, and we made sure that it was designated and made easy for the Viking engine. The Viking View is different, that it shows you on the bezel what you're looking at. A regular EIS does not do that. There's no mention of oil temperature, oil pressure, fuel pressure, gearbox temperature, fuel flow, RPM, coolant, or voltage on a regular EIS, because you have multiple screens, and it's quite complicated. Here, everything is on one screen. What you're looking at right now is, prior to me acknowledging that I turn the instrument on, it will tell you the flight hours, okay, and the outside temperature. And I have an alarm already. My light is flashing. I acknowledge the alarm, and now I'm in the regular mode. Okay, I still have some alarms because the engine is now running. So my oil temperature is 80. My oil pressure is now 0. Fuel pressure is only 2. If I turn the fuel pump on, this will come up to 41 or so. Right there. Gearbox temperature is outside temperature right now of 71. Fuel flow, there's nothing because we're not running. The coolant is at 81, no RPM. Voltage is showing low because we don't have the alternator. We want that to flash below 13.4 volts because that tells us that the alternator is not putting out, and this is super critical. We want to make sure that if we ever lost the alternator, that we would go and direct the airplane towards a place to land. Now, this engine is started by turning a battery on. I usually turn both batteries on, either one fuel pump or the other fuel pump. You want to alternate that because sometimes you want to circulate fuel so it doesn't get stagnant. You can start the engine very easily on the key. You'll now see that the warning on the Viking View went out. We have 1800 RPM. We can lower that a little bit right here. 1570. We don't have a propeller on, and feel free to run the engine without a propeller for short times. Coolant temperature is going to rise. The alternator is now charging. What we want to educate you about is that you can now shut down the battery number 1 and battery number 2. Now you'll see the voltage getting erratic. That's now because the engine is running on the alternator. So this engine is actually self-sustained, kind of like an engine with magnetos. It has a built-in alternator, just like a magneto, and it can run on that. And we have your backup battery and your primary battery. And what I usually do is you fly one leg on one battery and one leg on the other battery to keep them both charged. Now, in order to shut down this engine, since we can turn both batteries off and it still runs, we have to cut the alternator field or the fuel pump. The reason that we want to do the field on the ignition key, like we explained outside there, is so that we have a means of testing that when we cut the alternator, the engine shuts off. So that's a procedural thing, and we'll maybe cover a little bit more of that at the end of the video. Here's that gauge we were explained before. This is for our header tank. It'll read full when it's 2.5 gallons. that covers the instrument. Why don't we cover some of the other things that are on this instrument panel while we're sitting here. Of course, you saw the Viking view and the warning light, and then we can move over here, and we're going to tell you that there are at least 3 breakers that you would want to install to do a Viking engine installation. You're going to want a breaker for your ignition circuit that cranks and starts the engine. So the power that goes to this ignition key goes through this breaker. This is on the wiring diagram on the website, but we'll just go through it here so you can see physically what's really happening. So you're going to power up this breaker that powers this, and then you're going to need a 10 amp breaker for each of the 2 fuel pumps, which is here and here. This last switch you'll see in the diagram, it's the only switch that has 3 terminals on the back of it. And you want to wire that. There are 3 wires that are the select wires. They select if you want to run on computer number 1 or computer number 2. You want the switch to be down all the time, and you're never really going to use this. The only time you're going to use it is sometimes you'll start the engine just to make sure that the backup computer is working, but it is not like a second magneto. You don't test this between every flight. You test it twice a year. So, but it has 3 wires on the back of it, and all 3 of those wires come directly from the engine harness that's supplied with the engine. It'll say computer number 1, computer 2, and select. The select goes to the middle of the switch on the back side. Computer 1 goes on top, because when you have the switch off, it goes to the top terminal. And computer number 2 will be on the bottom of the switch, also on the diagram. The two first switches are very simple. If we can hear it on the video, I'm not sure, but there's a click, an audible click in the back of the plane. And all that is doing, it is grounding the solenoids in the back in order to turn the main battery contactors on. And we're going to go in the back of the battery and look at that in a little bit. Now let's take a look at these switches from the other side of the panel, since this is the primary wiring of the engine itself. What we've got is the ignition switch mounted here to the top. We did see the alternator wiring out on the engine a second ago, and one wire we described it as the top of the T. Well, that is the alternator field, and you want that to go to your ignition output of the key. What the ignition output is, these ignition keys are very universal and they're pretty standard, so you don't have to get confused about them. Usually they have a straight up and down with the key, and if you turn it this way, you're on accessory. Some of them don't have accessory, but this one happens to have accessory, and we don't use it. There's nothing there, and we don't want to put anything there because we don't want to put anything here other than what runs the engine. The engine needs to have its own designated wiring system, and nothing needs to be put on there that could possibly short out or take down the running of your engine. The first click on this key switch powers up the ignition terminal. Now, let me backtrack a little bit. Remember I said we had 3 10 amp breakers? One was for the ignition. Well, here we got power coming in from our power bus over here, and we run a wire and we power up these 3 breakers. We like to put a bus bar across them because it just keeps everything nice and organized. So here's power to our breakers. One of the breakers powers up the BAT terminal, B-A-T, the battery terminal of the ignition switch. There's where there's already power. We turn the ignition key, the first click, suddenly we got power down here to the ignition. Well, the ignition, the way we're using it is to power up the alternator field so that we can run the engine on the alternator by itself and have a means of shutting it off when we don't want the engine to run anymore. Otherwise, the engine will continue to run forever. We wouldn't have any way of shutting it down. We could shut down battery 1, shut down battery 2, and it would just keep running, unless, of course, we starved it for fuel by turning the fuel pumps off. Now, the other function of this switch is to power up the starter solenoid so we can physically crank the engine. And that's the second, that's the spring-loaded part of the switch. Okay, the one that when you let go, it goes back, and it goes back to the ignition. So this wire goes out to the starter solenoid, which is out here. That's also something that you would wire. The engine will come with this little pigtail, a plug that goes on the starter, and from this pigtail you would join in a wire that would go to that terminal. Let's cover the, let's quickly go through the lower switches on the panel. What we showed initially from the inside was that this last switch in the row is the switch that has the select wiring. So 3 wires coming from the computer, one on the bottom, the select in the middle, ECU on the top, or computer 1 on the top, and computer 2 on the bottom. You will see this system go away in the next year or so, but for now this is how it's wired. There is a select feature. These other switches, the first 2 are the ground switches. There are 2 wires that come, one from each contactor at the back of the battery. At the back of this airplane, the batteries are mounted. On some airplanes, or most airplanes, the batteries are actually up front, either in this area or in the engine compartment. We prefer this area, somewhere in here, if at all possible, because of the lithium ion, trying to keep them at an ambient temperature. Because this is a large engine for this airplane, and also with smaller engines, the battery trays have been mounted in the back, just as it is with the Rotax installation. Being that the battery's in the back, the contactors that turn the batteries on and off are in the back. And that's what these 2 first switches do. A wire comes from the contactor to one side of this switch. The other side of this switch goes to our ground terminal. When we turn the switch, we are grounding the terminals in the back on the contactors, and they click open. And the same with the other one. The 3rd and 4th switches have power going to them and then to the fuel pumps. Okay? We have 2 more breakers. They supply power to one side of these switches, and the output of the switches go to the fuel pumps, and it powers up the fuel pumps and make them run. Now, let's cover these buses here. You want to designate a ground bus and a positive bus for the Viking engine. And those should be separate from anything else. You don't want to clutter them up with your avionics, with your with anything. They are designated engine power bus and engine ground bus. We have a neat feature here where we mounted them with ADAL clamps, because once this is all closed, you can actually get underneath here and you can work from the bottom up, because it's not easy to do in most airplanes. So we made that. We believe that if you cannot access the terminals of what you're working on, there's no way you can keep it reliable. You cannot be sure that this has the right tightness. You cannot make sure that it has a lock washer on it. You can't make sure that all this is exactly perfectly straight and organized and safe if you cannot see what you're doing. So you have to mount things for the engine, such as the computer and your buses, in accessible areas where you can work comfortably and do a good job. Did I mention that wiring is extremely important with the Viking engine? And in fact, if you are not capable of doing this kind of wiring, this kind of quality, you need to do a course in how to do proper aircraft wiring, get help from an avionics technician, or just learn, because just like everything with a home-built plane, you need to learn how to do it differently than the way you would work maybe on your lawnmower, because it's not the same thing. We power up this ground bus with a large wire. This then has jumpers here that tie all these together, and that makes me able to put all the grounds right here. This is the main cable coming in for ground. It comes from this grounding lug right here. This grounding lug has a heavy cable, a number 6, coming all the way from the battery in the back, and it passes through the firewall. And prior to passing through, we tap off here, and this is the ground for the inside of the airplane for the engine. So it goes here, and it power. We have our grounds for like fuel pumps and a few other things that are related to the engine right there. We also have a power bus over here. The power bus gets its power from the positive terminal of the battery in the back. And the way we have done that here is that we run the battery cable all the way up front, and we run it directly to the starter. We have a large number 6 cable going directly to the starter. Now, because that's an unbreached cable all the way from the battery to the starter motor, we have no way of getting power to the inside of the airplane except this way, which is here we also have our alternator coming through this fuse, and we have a number 8 cable running here, and we're teeing it in at the starter. So now we have two cables here. We have the main battery cable, number 6 cable, and the alternator charging cable, which is a number 8 cable. Now, this gives us a convenient point right here on the output side of the alternator fuse to pick up the power that we need to power the inside of the airplane. So we're now bringing this through here, and we're always following. We never go right across. If you notice this wiring, just as a little hint about how to do your layout of the wiring, you wouldn't come here and jump across here. It's just not how it's done. Even if you add a little bit of wires to go all around, it just, when you're all done, it looks more professional, and it is more professional, and it's better, easier for troubleshooting. And we power up our power bus just like we did the ground bus with a large terminal right here. And then we jump these together right here with these little jumpers, and that enables us to have power at all these screw terminals right here. Now we're going to move towards the rear of the airplane, and we're going to zoom in on the batteries, and I'm going to explain how this is set up back there. What we've got is, first of all, a physical mounting of the batteries. We've got two 360 or 36, number 36 Earth X batteries, which Viking does sell. They're superior in many ways. They have a lot of cranking amps. We can tie both batteries together the way they're wired if we need even more cranking amps. They're very lightweight. They are expensive, but they last a long time. What we've done back there is you can see we've created a battery tray, which doesn't have to be very, very strong like if you have lead acid batteries, because the battery weight is very, very light. So we took some L-angle. In fact, we used bent angles out of sheeting because otherwise it'll get too heavy. And we made a tray just by going around the batteries at the bottom with L-angles that we pop riveted down into an aluminum sheet that was held to the airframe with A dowel clamps. So that gave us a little base for the batteries to sit in. Then we put a little foam pad on top of each one that came with the batteries, and we made a strap to go over them to hold them down. So that's the physical mounting of the batteries that you have to do. After you have physically mounted them, we like to have the positives at one end and the negatives at the other end. You want to tie the two negative terminals together. Again, you want to learn how to make aircraft quality cables using only aircraft quality Tefsol or Teflon coated wire with tinned strands from spruce or in your grab bag. And then you tie the two grounds together, and then you go from one of those terminals and you go directly to the engine. The most important thing is to ground everything securely to the engine. So the two batteries go directly to the engine. The other thing we've got going is we've got two contactors mounted. And if you get your wire diagram out and look at that, you will see that there's a wire from each of the two positive sides of the batteries going, each one goes to the positive input side of a contactor. There are two contactors, they're kind of hidden there. One is underneath the strap. One wire goes to the battery input of one contactor, one cable goes to the battery input of the other contactor. Now, what this gives you is two separate inputs to the contactors. The contactors can be turned on and off, so now we have a way where we can select if we want to bring in one battery, or we want to bring in the other battery, or we want to bring in both batteries. So guess what? At the output side of the contactors, we tie them together. So now when we turn both batteries on, one battery on or whatever, that output is tied together, and we can then use that to power whatever we want to power in the airplane. We also have a standby battery if we're only flying on one. The other one becomes standby. We fly home, we fly on the other battery, the primary becomes standby. So they do exactly the same things. One is not like a small battery and a big battery. They're both equal and they do the same, but you always have a spare and a backup, and you do have extra cranking power when you need it, and so forth and so on. Whichever battery is hooked into the system with the contactor, meaning the contactor is closed, is also the one being charged. So it's prudent, or it makes sense then, for instance, in the winter, if you start the engine on both batteries, you might want to leave both contactors closed while you're taxiing, because this gives both batteries a chance to charge again. Now, while you're cruising along after you're flying, you might want to shut one battery off, because if something happened, like you lost your alternator charge and you didn't notice it or something, you would then drain both batteries. And that's the other purpose of having two, is that one is sitting there waiting for you the day that you might need it. Now, looking at the contactors there, you see, and also on the diagram, that they have a little diode going across. The diode is going between the battery input terminal and the little ground terminal on top of the battery, the small screw on top. And the stripe of the diode goes towards the big lug, where the power comes in from the battery to the contactor. In addition to that, on the small screw on top, there's another wire attached to it, and there's one wire attached to it and also to the other contactor, and those are the wires that run up front here, and they get grounded. You ground that and the battery contactor will physically close. And so that's really all there's to that back there. You have two batteries, two contactors, you wire the grounds together to the engine, positive in to one contactor, positive in to the other contactor, a wire to the small terminal that also has the diode that goes up to the front here in order to be able to turn the switch or ground it and turn that contactor on, or the other contactor, or both for engine start, and so forth. So that's how that's controlled back there. Now, we're going to cover a little bit more in detail the physical or what's really happening here with the engine, so that you know more about your own engine. You've got your gearbox up front here. The gearbox now uses high pressure oil it's tapped off here, and it goes through this line and it comes in here, and it lubricates and cools the gearbox. The oil is then drained by gravity back into the oil sump of the engine. From the oil sump of the engine, there's a pickup tube at the bottom here that goes down in here and sucks the oil up through this hose. It goes back here into the oil pump fitting of the engine. And that is driven by an oil pump that is right around the crankshaft of the engine, a very reliable oil pump. You've got your oil filter here. What you want to do there is, it does in fact make a little bit of a mess when you change oil, but the secret, of course, is just get a bunch of paper towels and just stuff them around here, and that takes care of that small inconvenience. You can get a regular automotive filter for it. These are your crankshaft sensors for the primary computer and the backup computer. There's a toothed wheel inside the engine that gives these the signal to when to fire the spark plugs. This is your flywheel and your flexible coupling that should be replaced every 500 hours, or any time it shows any kind of sign of wear and tear. This is your bypass that we covered, coming off your thermostat when the radiator is not being used because of the thermostat location. This is your air cleaner and your air filter or air inlet temperature probe for the computer, so that it has a way of measuring that. This is your coolant pump area with your coolant pump. See, I don't say water pump because there's no water in this engine, as we talked about, using NPG coolant. This is your sprocket to drive the coolant pump. This is an idler pulley that is used in the system for the 5-groove serpentine belt to drive everything. These are crucial grounds to the engine, or a crucial ground. This is why this is very nicely done. It has a stud in the engine. It uses washers to separate the terminals, and this is the ground for all your computer electronic hardware stuff. So this needs to be in good shape and nice and clean. Of course, it's already pre-installed, so there's nothing you really have to do with it. As we covered, you have your fuel injectors. You've got your coils. The coils are sitting on top of the spark plugs. It's a coil-on plug system. You remove this clip and pull that off. In fact, taking this off is fairly simple. Be very careful with your plastic pieces, your clips, so that you don't break anything. Like this. And then there's a little clip right here. You can pull this out and push this back, and this comes off. And then you take these out and pull this out. That takes your spark plugs out. You can do your compression check on your annual inspection and so forth and so on. Your valves have to be set occasionally. You'll get a feel for how often. Usually they never really need to be adjusted. It's just a matter of checking them. Now, sometimes I like to put these clips on prior to sliding that in place, because it gives me a little bit more wire, like that, and there. The okay, now as far as the installation, is very universal between this plane and other airplanes. As an option, it's nice to have heat when it gets cold out. Get your heater out. It's an option with the Viking engine. You can get it through our shopping cart. Mount it somewhere inside the airplane, preferably somewhere where either your feet or somebody else's feet or both are going to be hot. Now, what I would recommend is when you put it in, it gets installed by drilling holes through. These come off kind of tight right now, but we'll pull them off. Drill holes through the firewall that are oversized, where this would fit through. Now, the reason for that is, if you want to have them oversized, is you want your connections to be outside the aircraft. That way there's no hot coolant inside the plane. So your firewall is going to end up right up against here. And this is sticking through, and your hole is bigger than this. In fact, it's the same size as this, as the hose. And when you push this on, this seals off the hole. Okay, but you don't have to worry so much about a sharp firewall, because the clamp is on the outboard side of that. Your clamp's going here, and firewall's going there. So that's true for both this one and the other one. One, of course, is a feed, and one is a return. Now, this comes with a switch and all the fittings for the engine. Your switch is wired in a way, and that's shown in the diagram, where you can have one fan or two fans, and that's how you regulate the amount of airflow. You would physically mount it by pushing it through the firewall and then make a brace from here, either down or up, or hang it for something inside the plane. Now, as far as running the lines to it, or the hoses, you've got one fitting that goes in underneath this hose right here. This is the return from the heater. So a piece of this hose would go on a nipple that you screw in here with some white Teflon thread sealer, and then to one side of the heater, one or the other, it's not critical. The other one would have another fitting from your bag, and it screws into this fitting right here. You'd have to hold this with a wrench, unscrew this with an Allen wrench, because that's an Allen plug, and then at that point insert the fitting from your bag with the thread sealer on it, and then add your hose, and then route it underneath the engine and in the back, and secure it in a few places to the engine with 8L clamps. And that's all there's to the installation of the heater. Now, let's go over here and look at some of the other things that are involved. Let's for instance cover a couple of little quick things, like I've been talking about O-ring grease. Well, this is O-ring grease, okay? As you see, we use quite a bit of it up through the years. This is 55 O-ring grease by Molly Coat, and you know, of course, it has part numbers and everything else right there. One good place to get things are from McMaster Car, and you of course can get this in a little tube. You don't need this much of it. Here's this firewall pass-through from aircraft spruce. It comes in 2 pieces, and that's just, you drill a hole and it goes in and snaps in, and it gives you enough room to put your screws in there when you're done. You can seal it when you're all done with maybe some O-rings or sealer if you want. These are the O-ring or the Oetiker pliers that are used. This is a special type that has a side one too. We use this in the shop because sometimes it's hard to get in forward like this to squeeze those clamps. Sometimes you have to come in from the side. The ones that we send out with the kits are front loaders like that, and 99% of the time that's good enough. Now be sure that you're actually physically on top and bottom. The worst thing that happens is if one slides off and you kind of squeeze it into an egg shape, then you have to find a way to get it back off, and you do that by taking some small diagonals and you put them between this corner of the clamp and this little thing right here, and just pop that and peel the clamp off. But this is used throughout with a little bit of O-ring grease inside. That's one technique. Here are your fuel pumps. These are already on your fuel system in a box if you're using that. Low pressure filters and dual fuel pumps. The plus and minus are embossed in here. That's very faint. It just says a negative sign there and a positive sign there. And the hardware already comes with them with lock washers. Make sure that when you attach here, first of all, these clamps have to be on this side. You don't want this up in here because it could short things out. Tools that you're going to need for the installation are cutters, you know, dikes, and stripping tools for wire. You'll find that even as a seasoned electrician working on your house and stuff, that when you do aviation wire, one trick, because of the Teflon coating and the very slippery coatings, is to score the wire with a size slightly smaller than required, or the size required. Just close it. That cuts the wire, but don't pull, because that's too small to pull. Now after you cut it, move the wire over 1 or 2 and then pull it, and you'll get a nice clean cut even on the difficult to work with tough cell wire for aviation. Get yourself the ratcheting style professional squeezers for the all the terminals, and make sure that when you push the wires in that you can see them on both sides, and that it makes an excellent crimp every time you make a connection, because you don't want wires to fall apart on this installation. Here's the Evans coolant. It is included in your grab bag, 2 gallons of it. You need 2 gallons because the engine holds a little bit over 1 gallon. So that gives you a little extra. The propeller that's supplied in the Firewall Forward kit with Viking is the Whirlwind. It's a nice propeller. It has carbon fiber blades. It's a very beautiful propeller as far as the way it looks. It has the carbon weave showing. The protractor is supplied, which you slide down the blade, and that will give you a way to put your smart level on there and set the pitch of the blades. And they have to be within 0.1 or 2 degrees for the engine to run smooth and not transmit vibration. The spinner that Viking supplies is of their own design. It's a spinner dome out of glass fiberglass. It has index marks here. It is unique in that it uses a single dome with little index marks that line up here, and no screws down here. Make sure that it's inside everywhere. This goes on the front of the propeller inside here, bolts that in together. And I might as well mention here now that there are 2 sets of holes. Use the outermost. They look the same, but the outermost holes are the pattern that we use with the Viking engine. That goes on top with the propeller. Then this goes on, and the index marks are lined up like that. And then you have your blue, you put some blue Loctite on this bolt, this goes on, and then that screws into this piece that we showed inside. And for tightening, after you make sure that the spinner is sitting in the groove, you just want it just tight enough. You can still move this around, and then snug it. Just it's a matter of like 1/8 of a turn at a time until it just locks in by itself. Now we've got some hardware for the propeller, and they're just bolts. But what is unusual to some might be that they use a Norlock washer. Okay, it is not safety wiring. As far as safety wiring the propeller, what you're doing is you're using this Norlock washer. The Norlock washer can fall apart because it consists of 2 pieces. If it does fall apart, you'll see the coarse part of it is what mates together, and the small serrated parts are what's supposed to be on the outside. It goes on the bolt, and then the propeller hub goes on, and everything gets bolted together. And when you bring this up to torque, the type of design this is that it would take more torque to break the bolt loose than it is to tighten it, which means safety wire is not required. Now, being that this is all aluminum parts, I would still go back and re-torque, until you get comfortable with that it's not backing out by itself. Now, another thing when we go over to the engine here and look, that we're going to see is that most Viking engines have a spacer attached to the front to make it easier to fit the cowling. Now, the propeller and the spacer is bolted in together. So the bolts run all the way through the spacer into the lugs that are provided with the engine. And that's how it's set up. Okay, you've got your engine installed and all the systems, and where do you take it from there? Well, you take what you do is you fill the oil canister through here with of course I've had people take this off and fill through here. That's not the way to do it. You want to pull this whole thing off, otherwise you fill the whole gauze screen in there with oil, so that's no good. So pull the whole thing off, fill this up with 3.5 quarts of oil just for the first startup, and then check your dipstick and keep adding until you're right at the money with the oil. The reason you don't want to put all the oil in at one time is that some of the oil will get distributed throughout the engine. For instance, some will be left in the oil cooler, and some will be left in the gearbox. So 3.5 quarts will put it up to enough oil in here that the oil pump will pick it up and distributes the oil. Then shut the engine down after like 30 seconds, and then add a little bit until you get right up between your marks on the dipstick. The type of oil you want to use is, as far as the weight, you want to use 2050 weight oil, unless you're really, really far north than the 1030 in the wintertime. You do not want to use any kind of synthetic oil for the first 100 hours. And you don't want to use synthetic oil if you use 100 low lead fuel. You can use a semi-synthetic if you want to use a kind of synthetic oil, a blend or a semi-synthetic oil. The oil filter is a standard part. Just match it up to the filter that came with your engine at an automotive store. And those can be replaced anytime, even if you don't change your oil. It's super easy to spin it off and put a new one on as often as you want to. The fuel filters are located by the pumps. There are 2 low pressure filters and a high pressure filter. The reason for the low pressure filters is, of course, to pick up all the dirt or any dirt that gets into your fuel system through the tanks. Any kind of little shaving off of a hose or anything at all that could stop up a fuel pump. The high pressure filter is used just in case something happened to the low pressure filters where they started this coming apart, or the fuel pump itself started deteriorating and a piece of something came out of that. So we do use a high pressure last resort filter prior to the fuel injectors. As far as fuel, Let me mention that the fuel injectors are susceptible to becoming partially clogged, and it'll give you harder starting, longer cranking. The thing that will keep the engine from starting instantly are weak batteries and fuel that's been sitting in the fuel injectors for prolonged periods of time, causing varnish and sludge and stuff that you don't want in there. If that ever happens to you, throw the injectors out and put new injectors in. The 100 low lead should not really be used as an everyday diet for the engine because eventually lead will pile up on the rings and compression will slowly start coming down. So use it when you're out flying, going places, and then when you get back home, use car gas. Be careful with car gas in composite airplanes. There's lots of accidents from that. You don't want gasoline with ethanol to sit in composite wing tanks. I do recommend using 100 low lead prior to shutting the engine down while it's sitting, because it's a very stable and clean fuel, and the fuel injectors would stay quite happy if you put 100 low lead in and then ran the engine and then let it sit. If you're going to let it sit over the winter or you're going on vacation or something, put 100 low lead in prior to shutdown. The oil pressure of the engine should run about 35 to 80 pounds of pressure. In cruise, after prolonged cruising along, you should be seeing 55 to 70 pounds of pressure. The oil temperature should run 190 to 230 to 35. Your gearbox temperature is the same. In fact, the gearbox temperature has now become the most normal, or the gearbox temperature is in essence your oil temperature. The hottest part of the engine, which happens to now be the gearbox, is the place that you want to measure or read and evaluate what is my oil temperature. If your gearbox temperature is 220, that's perfect, and that is now your oil temperature for the engine, because even if the oil temperature says 170 on the engine probe and the gearbox says 220, you want to use the 220 as your guide as far as how hot your oil is, because the whole point of getting oil up to temperature is to gauge if moisture is being boiled off from the oil. So use your highest temperature as your quote-unquote engine oil temperature, the one that's accurate. Your coolant should be very close to your oil. Anywhere from 180 to 230 is fine. So you have quite an operating range that you can work with as far as the temperatures. On the exhaust, there is a bung provided in the back if you want to use an air-fuel ratio meter kit that you can get on most every race shop or eBay or so forth, Amazon. Air-fuel ratio sensor. It screws into the exhaust, and you can read your air-fuel mixture in flight if you have interest in that. It's a nice troubleshooting tool, and we often use it on our engines. You can read up on that on your own if you'd like to learn more about that. As far as maintenance, change the oil basically when it starts getting dark in color. Keep your fuel clean and filtered. I would go around on the engine and check every bolt and nut for torque specs after you've run it for a few hours. All these bolts, just go over them. The 6mm is usually 200 inch-pounds. The 8mm is about 280 inch-pounds. These are in the manual as far as how much torque. Just go over everything, anything you can get a wrench on, and make sure everything is nice and tight. The oil cooler is there's no real maintenance there. One thing that I like to do, rather than putting a duct in between the cowling and the oil cooler, is to physically make something that is stationary here, so when you put the cowling on, the air just kind of goes into it, because otherwise if you have to disconnect it each time, it won't be many times before you forget to hook up the duct. You leave, you depart, the oil temperature is really high, you say, oh my gosh, I forgot to put the duct on, you got to return and put it back on. So it's a nice thing to be able to just have that, so that you put the cowling up and the duct just lines up with something that goes right into the oil cooler. That's really all there is for maintenance. As far as a procedure, how to operate the engine, you're going to be getting into your airplane, have a seat, put your seat belt on, blah, blah, blah. Now, what's different about it is that you are in an engine, and you're in an airplane that now has a modern, up-to-date engine. It has a computer that operates it. We have the computer mounted, by the way, over here on the firewall. We want to make sure that the connections for that are tight, and the vacuum lines going to it are tight and routed properly. The procedure is very similar to other airplanes. You're going to check your fuel, you're going to check, make sure the airplane is safe in every way. But other than that, you would want a few things. You don't want this battery to come off in flight by a map or something, okay? And you don't want the other battery, and you don't want your fuel pump. You don't want any of this to move in flight inadvertently by dropping something on it. So you either make an L angle behind all these that come up and over, that gives a little shelf over all your switches, or you order in little switch guards that go in between here, little bows, or you do something to protect your switches, because you want to be in control of those. You don't want to be on short final and you think you're grabbing your flap switch over here and you're grabbing the battery, and guess what? Everything gets really quiet. So you don't need that on short final. You do want to operate all these 4 switches in the beginning by procedure, as in, I'm going to fly to have my pancakes on these 2 switches. I'm going to fly on this battery and this fuel pump. When I fly home, I'm going to fly on this battery and this fuel pump. That keeps everything exercised, all the fuel flowing through the pumps, nothing gets stagnant, both batteries are up to speed and charged. The last switch, which is going away with the next generation of computer, is there to select the other computer. There's 2 computers in the same housing. Basically, it is never used. It is a last resort thing, and it's just if for some reason, which has never happened, the circuit board in your computer just happened to die inadvertently while you're up flying. It has never happened. It has actually been more of a nuisance than a godsend to have it, because people miswired and all that. But you will never use it, so you might put a guard on it unless for some reason one day you're flying along and you've switched pumps and batteries and you can't get the engine restarted, or you're having an emergency. Then you go to the backup computer to see if by chance it was the computer. But other than that, it is always down and never used. I get people ask, oh, there's no RPM on the backup. Well, guess what? You're not going to need RPM on the backup, because you're never going to use it. And if you did, you're just going to be happy that the engine is running, never mind the RPM. So that's basically all you got going on here. Of course, we do recommend this. It's the best thing ever. I think that even if I had a nice fancy EFIS here, I don't want to have my engine on my EFIS. I spent all this money on my EFIS. I'm going to have the Viking view as a separate thing with the engine, and then I'm going to have my moving map and everything on the EFIS. So that's just my opinion about that. Other than that, be part of the forum. It's important. Viking Aircraft Engines has a forum. You can get to it from our website. And we have a shopping cart where you can buy things for your Viking engine. This video is going to be on YouTube, and you're watching it maybe there now. It'll also be on our forum. It's going to be available for sale as well at a very reasonable price at homebuilthelp.com. And that's probably your best option, is to get that copy, because now you can bring it with you, have it in your laptop, watch it anywhere you want, downstairs, you're working on your plane, or out in the garage, or at the airport. So this is a video that would be handy for you to have anytime you have a question about how to operate or how to install anything about the Viking engine.